My name's Jason Vandiver, Energy Code Program Manager for SPEAR. Just a little bit about myself. Before joining, I've been with SPEAR for about 5 years. Before I joined SPEAR, was the chief building official for the city of Granbury. I've been a city inspector for city of Temple. My dad's a carpenter. I grew up on framing crews in the Dallas area. It didn't take me too long to realize that's too hot and hard to work. So I got into the inspection business for a while. And then now I'm a tree hugging hippie working for an energy efficiency nonprofit. But I try to kind of blend the three worlds together and try to find some things that work in reality, because I'm sure y'all have all read the IRC before, and you just can't build a doghouse to code. You darn sure can't build a house to code. That thing can get complicated, and then you add on top of it manufacturer's installation instructions, which, you know, they're not only can they be, anyway, it can be a lot to get something built to code. So what we're going to talk about today, and copies of the slides, I'll send a PDF of the slide presentation, and then also they're recording it. And then also I'm going to cover some good resources on some websites to look at. So I'll make sure and include those links. A little bit of coffee there. Okay, so let's get started. So what are we going to do today? Who is SPEAR? We're a regional energy efficiency organization. We cover Texas and Oklahoma. Great thing about SPEAR, we are a nonprofit. So feel free to ask me any questions. And I'm a bit of a code nerd, so whether it's plumbing code or mechanical code or fuel gas code, I like them all. And if I don't know the answer, I know somebody that does, so feel free to reach out. We cover Texas and Oklahoma. Most of my training and education is energy code centric, so I highly welcome your energy code questions. If any of you folks are in the San Antonio area, I live in San Antonio. I'm always happy to get out in the field and do some field training. Happy to do that. If any of y'all are ICC certified and I need some ICC CEUs as well for today's presentation, just shoot me an email and I'll make sure to get you a ICC certificate if you need that. So let's get started. I like to leave this slide in Spanish on purpose, because it gives me a chance to kind of translate it, what it means. And I started putting Spanish on all my slides. You'll notice most of my slides have Spanish on them here as well today, because I was doing a lot of installation training for the North American Insulation Manufacturers Association last year. And you could have 60 insulation installers in a room and 2 of them might have spoke English. And just with construction trades in Texas in general, if I was going to be effective, I can't speak it, but at least I could have it on my slides. And this is one of the more important slides, and this really goes to the heart of what I believe in. And you know, when I was a building official in Granbury, that my deal was, if I went to a class or whatever, I wouldn't come back to my builders and hit them with a red tag of all 20 things I learned at that class. No, my goal was to incrementally improve and to get better. And basically what I tried to impart to my builders is, hey, let's learn one new thing a month. Let's get a little better. So as real estate inspectors, you know, if you've been doing it 10 years and you're still highlighting the exact same 20 things you've always highlighted and you're not catching any other things, I would encourage you to get a little better. And this slide here basically says, you know, my previous presentation was all energy code related, and a lot of the items that you can catch on a real estate inspection that are energy code requirements. I'd highly encourage you to go back and watch that video once those are posted, because there's a ton of things that you can catch. Air barriers on the unconditioned side of knee walls in attics for new homes, for example. There's a bunch of stuff you can catch. And what this slide basically says is, you know, catching these little things and making a difference. You know, if you can save somebody $10 a month in their utility bill because of you getting it through the builder's brains that, hey, y'all got to do this right. So when you go do inspections on COs for new homes, if you're doing it out in the county and the builders are cutting corners or they're not following the energy code, well, a single mom or little old couple on a fixed income, if their utility bill is 20, 30, 40 bucks a month, every single month, more than it should be, if that house just met code, you know, that can be, that's only a You know, that might only be a case of Dos Equis for me, but for a single mom or a little old couple on a fixed income, it can make a big difference. So this slide basically says, don't underestimate the job you guys do. It's very important, muy importante. I appreciate the jobs you guys do, and I know it's difficult, and calling out some of these energy code related requirements and some of these HVAC related requirements that we talk about, these all save energy. These all make it less expensive for that single mom or little old couple. So let's get started. What are we going to talk about? Well, I used to do this. ACCA funded a lot of these trainings in the beginning. And this is just kind of interesting. And it basically it alludes to the fact that our residential HVAC equipment is oftentimes installed wrong and not very efficient. So ERCOT is basically the electrical grid for Texas. I'm not going to get into the details of the differentiation, but long story short, this is the total electrical profile for the electrical grid in Texas on a 62-degree day in Dallas. Well, you see that residential is about a quarter of it, right? Well, on a 106-degree day in Dallas, residential goes up to almost half. But look at, how small commercial about doubled in size, large commercial got a little bit bigger. The reason residential, not only are there more homes, but a big reason why the residential goes up by a factor of 5 like that is because of poorly installed and oversized equipment. And so that's what we're really going to be talking about today is ACCA manuals, JS and D. I don't have an agenda on here. So what we're going to cover today, I'll spend the first 30 minutes or so talking about ACCA manual, JS and D, where it's in the code, why it's required, why it's important. But then we'll take a step back and say, okay, I live in reality. And if you're not going to do it 100% by the letter of the law, 100% by code, here's at least some best practices to think about. Here's some flex duct guidelines to think about. Here's some structural considerations. So we'll kind of spend the first third of it talking ideal world, 100% code compliant, and then we'll spend the last hour or so talking about just some things to write up in your inspection reports and some best practices for flex duct. And then I'll spend about the last 10-15 minutes. I've got about 6 or 7 websites I want to show you that are just good resources for good building science information going forward. So let's get started. So working for Spear is pretty handy. I'm able to get into a lot of the building science stuff. We do different field studies. So we did a big Texas Energy Code field study. We did data collection in 2015 or 2014 and then again in 2018. And basically what we wanted to look at how well homes were complying with the energy code then. We did a bunch of training and outreach, and then we went back and looked at homes to see how well they were acquiring now. And as you look at the bullet points there, and you look at some of the things we did, I'm gonna grab a sip and then we'll go to the next slide. So this field study was done across multiple states. This is the average installed square foot per ton. Well, we would expect Maryland and Pennsylvania, although Pennsylvania is worse. Pennsylvania is just, their HVAC contractors must be terrible because their duct leakage was really bad as well. But Georgia, pretty hot like Texas, right? But Georgia has a statewide code, and they've been requiring manual JS and D at permit for a while now. So the HVAC contractors are accustomed to doing it correctly. When you're doing it correctly, even on a southern state in a cooling dominated climate, you're getting almost 900 square foot per ton for new construction. In Texas, unfortunately, most jurisdictions don't require manual JS and D. So most jurisdictions get the old 500 square foot per ton rule of thumb HVAC contractor installing the systems. That was fine 25 years ago, but we'll have some slides and we'll talk about lots of reasons why that's a problem now. As a track inspector, if you're seeing less than 700 square foot per ton, I can without a doubt assure you that they are not doing the load calculations correctly. Now, granted, if they grossly undersized the return, I was walking a 2,100 square foot, 3 bedrooms kind of starter home in Bryan College Station. Was doing some field training with the building official there not too long ago. And they had a 5-ton unit in the house, right? So was that 425 square foot per ton, grossly oversized unit. But luckily they had one 16-inch duct for a return. So they had a grossly undersized return. And then also luckily they didn't mastic any of the liners to the boots. So they had really leaky ducts. Well, College Station amended out the testing. So we'll never know how leaky it is. But that calamity of errors, that thing being 3 tons oversized with a grossly undersized return with really leaky ducts, it probably kept the occupants comfortable. So it works, don't it? What's wrong with it? Well, what's wrong with it is it's an energy pig. The builder could have saved $3,000 on the initial equipment install by putting in 3 less tons. He could have passed on $2,000 of that $3,000 savings to the home buyer. The home buyer could have saved $2,000. The builder could have saved $1,000. We could have put a return in every bedroom along with that 16-inch return, and we could have sealed our flex liners to the boots, and the occupants still would have been comfortable, but yet they would have a more efficient, more longer lasting, better system. So just because it works, just because it keeps people comfortable, doesn't mean it's correct. So I talked about that field study we did. Each of these dots here is a house. So we went and looked at, this is actually 70 different homes. So there's 70 dots here. And anecdotally, these numbers align really well with, I had about 600 HVAC contractors and HVAC trainings where I gave largely about 80% of the slides were from this presentation here that I gave to the HVAC contractors. And 19 out of 20 HVAC contractors, you know, when I preface the question with, hey, I'm not judging, I'm not turning you in or anything. I'm just curious, who does a manual J load calculation for all their new construction? And 1 out of 20 HVAC contractors would raise their hand. Well, I would argue, so each of these is a home. So 700-ish square foot per ton. I can live with that as a rule of thumb. I can live with it. I don't like it, but I can live with it because I live in reality. I would be willing to bet anything. We had 4 HVAC contractors of the 70 that did an actual load calculation, and look at where they all came out. 900 to 950 square feet per ton. I know people that do these load calculations for a living. I know people that own companies that do load calculations and installs. You never trust just the guy doing the paperwork, right? If he's not actually out in the field installing it and warrantying it, I don't always trust those guys, you know, right? But if they're actually installing it and doing the calculations, I'm guessing these 4 were done by the book. I can live with these rule of thumb. These are all grossly oversized. And then this one here, 280 square foot per ton, that was sized for the 4th of July party, which, yeah, it keeps everybody nice and comfortable on the 4th of July party, but it is grossly oversized, short cycles, causes energy penalties, leaves moisture issues. We'll talk about some of those other issues that this is going to cause. I had a litigator, like one of the, anyway, called me that, oh, we're having mold problems in the house. There was a 6,000 square foot, 3-story house, brand new house in Houston that was having mold problems. Well, they had 21 tons of cooling in that house. It's never going to remove moisture, right? I mean, when you see the drip, 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 you know, something, lots of times, 15 years ago, they would run the condensate to the flower bed. Now they run it to the T&P or to the trap at a bathroom sink for some reason. But that condensate, well, I'll save it for when I get to that slide. So I want to show a real quick, I'm going to show about 2 minutes of video. This is a full 1.5-hour training. Just FYI, Spear does have a YouTube channel. We have 60 different building science related videos on our YouTube channel. 4 of them in particular were done by Alex Meany. He's their lead trainer with RightSoft. Sharp guy. And this just is another reason why you can't do square foot per ton in rules of thumb. I'm going to just play about 2 minutes of this video, but just FYI, it's a full hour and a half. He's really, really sharp, but I just want, this is another kind of highlight. Ooh, I did click share sound. Yes, I did.
So we're going to look at this two different ways. We're going to look at this, and I'm going to disprove the whole square footage thing. So if there's anybody who's like, but, you know, kind of
chat in the box if y'all can't hear that. I'm pretty sure I clicked share computer sound. If I didn't, I'll need to reshare my screen, but I'm pretty sure I did. So here we go.
No, it doesn't. Stop thinking that.
Awesome.
And I want to show it to you two different ways. So for those of you who are math kind of people, this will hopefully resonate. So we're going to take two very simple examples, but you can scale this up to a bigger house. I just like to keep the numbers small so we can wrap our heads around it easily. If you had a square that was 1 foot square, right? 1 foot cube, actually, a cube, but 1 foot cube. So it's 1 foot by 1 foot by 1 foot by 1 foot by 1 foot tall. You can take the surface area of that, and each of those surfaces, floor, ceilings, and walls, are going to be 1 foot, 1 square foot. And so that's going to be a total surface area of this shape of 6 square feet. So that means for every 1 square foot of this, there's 6 square feet of total surface area, right? But if I made this building 5 foot by 5 foot, right? And I make it 1 foot tall so that we don't lose the, you know, this would be cube square law, but buildings don't get that much taller, but they do get a lot bigger. The footprint gets bigger, right? And if I look at this, then this wall would be 5 square feet, so 1 foot tall by 5, and this wall 5, this wall would be 5, this wall would be 5, and the floor and ceiling would be 25 apiece, right? A 5 by 5 foot square. So for every 1 square foot of this, there's only 2.8 square feet of surface area, right? There's 25 square feet of floor and 70 square feet of total surface area. That means for every square foot of this, I have half as much, less than half as much square footage of exposure than I do for this one, right? Here's another way to look at it, okay? You see these squares? These are all somewhat similar to this one because they have exposure. But you see these, right? This 9 square feet here in the middle, right? This 9 square feet in the middle has no walls. It has no windows. It has ceiling and floor, but that's it. It's all interior, right? There's no way for there to be load on this except from the ceiling and the floor, right? So here's another way to think about this.
So I just thought that was a good example of just another example of why square foot per ton and rule of thumb, we've got to get these guys away from doing that. You know, and even a bigger house is going to need less square foot per ton. It just typically does. This is it's a great blog. Energy Vanguard is the name of the blog, a great HVAC blog. There's a mechanical engineer that writes on it. And one of the advantages of working for Spear is I can spend time on building science blogs. Long story short on this one, he was building a guest house and he did the load calculation and it came in at right at 1.5. He's like, man, it was like a 2,000 square foot guest house. He's like, I don't, first, and just, you know, you would think a mechanical engineer would trust the calculations, but he oversized it 0.5 ton. He decided, I'm 1,000 square foot a ton, you know, anyway. So even though he did the calculations, that new 2,000 square foot house he built, it should have been 1.5 tons, but he put in a 2 ton. No big deal adding 0.5 ton, right? Well, this green line here is the temperature outside, and this was in Atlanta. So it gets up to about 92, 93, like a June day in Texas, right? Well, he put a data logger on his air handler because he wanted to see when it was running and when it wasn't. Well, if an air conditioner is oversized, what it does is it'll kick on and it cools the house down quick enough. It might cool the house down in 7-8 minutes and then kick off. Well, depending on fan speed, manufacturer, there's a few variables, but typically you're looking at least 15 minutes runtime before that moisture that starts collecting on the coil starts dripping off the coil and going out of the house. So he put a data logger on. The blue is when it, or the blue is when it's on, the red is when it's off. At just a half ton oversized, that piece of equipment was only dehumidifying for 1, 2, 3, 4, maybe 5, maybe 6 hours of the day. It was running long enough to dehumidify. The rest of the day, it was kicking on, cooling the house down, kicking off. Well, if it doesn't run long enough, it won't dehumidify the house. And there's a ton of problems with that, right? So there's 3 components of comfort. Temperature, which is if you're comfortable, how often do you go over to the thermostat to adjust it? You never do, right? You never do. So temperature is one component of comfort, but frankly, one of the lesser important components, in my opinion. What's more important, especially Houston, Beaumont, any of you folks down on the coast, relative humidity in the house, right? And then airflow. So those are the 3 components of comfort. You're never going to walk over and adjust the thermostat if you're comfortable. Well, I know this anecdotally as well. So I had a rent house in Granbury, and on Saturday, the upstairs unit went out, upstairs air conditioner went out. And then on Sunday, the downstairs unit went out trying to keep up. You know, obviously it was in summer in Texas, so called the landlord the second it went out. But long story short, he sends the technician over there. They were both like 15, 16, 17 years old. He was just going to put in two new units. So the AC guy's over there, and he's sitting down at the condenser, writing down the model number, and he's just going to swap out like for like, right? And so I go out there and I'm visiting with him, and told him, I was like, oh yeah, I used to be the building official here. And he's just like, oh gosh, well, you know, why me? And then I said, yeah, now I work for an energy efficiency nonprofit, and the chief engineer for ACCA, that's the Air Conditioning Contractors Association of America, Glenn Hurahan, he's doing a webinar for us in the morning over manual J load calculations and HVAC sizing. And he's, then he's just really going, oh, what have I done? But anyway, so he goes, I tell you what, he goes, I'm not going to do a full load calculation, but I've got kind of a shortcut I've created on Excel. He goes, I'll run some numbers in. Long story short, now granted, this is just anecdotally, but I lived there. Long story short, he replaced my 5-ton downstairs with a 3-ton. He replaced my 3-ton upstairs with a 2-ton. So I lost 3 tons of cooling. I couldn't have been as comfortable, right? I mean, it was July in Texas. Actually, I was able to keep the thermostat on 76, and it felt the exact same, the exact comfort level. Then with 3 tons more, I kept it on 72. So why is that? Because with 3 tons more, I had to keep the house colder because it was oversized and it wasn't dehumidifying properly. So for comfort, our skin feels comfort. If it's more humid in the house, we need a lower temperature to feel comfortable. So I had the added bonus of being able to keep my thermostat at 76 and being comfortable. Obviously, it's cheaper to keep a house 76 than 72. The smaller equipment, typically, it's not as noisy. Larger equipment, what's called short cycles, kicks on, cools the house down real quick, kicks off. Kicks on, cools the house down real quick, kicks off. Never has time for the moisture to get out of the house. And then that short cycling, the big energy penalty is when the dang thing kicks on. I mean, once it's running, it doesn't pull. It's not too bad. Mitsubishi, in fact, has a variable refrigerant flow. I'm pretty sure Daikin has one too, that when running on low speed pulls less wattage than a 60-watt incandescent bulb, an air conditioner, when running. Now when it kicks on, it pulls more. So it's just getting these things sized right. And when you do the calculations, the manual J calculations, it already allows, there's a 15% oversizing factor built in. So there's already oversizing built in. And if it's variable speed equipment, there's a 30% oversizing factor built in. It's certainly not as important with variable speed because it can just run on low speed. It still matters. And it's super important with single speed equipment not to oversize it. So is this new to the energy code? Is this new to any code or no? This has been in the mechanical chapter of the IRC for 30 plus years. It's been in the IMC for 30 plus years. It's in the energy code now as well. It basically says you have to size your loads by the manual J load calculations. You really do need to do a room by room load, manual J calculations. And then what's required by code is that you select your piece of equipment. You're going to look at blower performance. You're going to look at latent versus sensible loads, what that equipment delivers, latent versus sensible, the CFM requirements. Will that blower deliver it? Manual S is required by code. That allows you to select the proper piece of equipment. And then the other thing that's required by code is Manual D. Manual D is basically your duct system design sketch. It's going to take into account your total developed length, your static pressure drop, your total effective length, how whether you're using duct board or flex duct, what kind of do you have. It gets as technical as stamped versus curved blade diffusers. They have different static pressure. They have different effective length numbers that are all incorporated into Manual D. All of that goes into the code to produce an effective, efficient HVAC system. The problem is, again, I live in reality. There are less than 10 jurisdictions in the entire state of Texas. Of the 1,200 I track, there's less than 10 that require a JS&D permit. So if you're not, we all know if you're not requiring it from the contractors, are they just going to do it? Now, a handful of them are. Positive Energy out of Austin. I mean, there are some we will not cut corners, period, HVAC contractors. Again, anecdotally and through surveys, 19 out of 20 of them don't do this. And I'm kind of, the energy code, again, that was the previous presentation. That 500 square foot per ton, it worked fine when windows were crummier and we didn't duct leakage test our house and we didn't blower door test our house. But now that we know our houses are tight, and now that we know our ducts aren't leaking, and now that we have really good windows, if you're still using a rule of thumb, you've got to go to that 700 square foot per ton at the very least. Again, I highly encourage no rules of thumb. TDLR asked me to put this one in. This not really relevant for Trek, but just FYI, if TDLR gets a comfort complaint, this last bullet point here is the most important part, is TDLR gets a comfort complaint from an HVAC contractor. The very first thing TDLR is going to ask that HVAC contractor for, and literally, they can just get hey, I had a new system put in and it's still not comfortable in my house. That's a comfort complaint to TDLR. TDLR is going to call that HVAC contractor, and they are going, the first thing they're going to ask for is a copy of their load calculation. Okay. And like my house with that HVAC contractor, if he would have just swapped out that 5-ton with a 5-ton and I would have registered a comfort complaint, he couldn't have retroactively shown that 5 tons because it wasn't a 5-ton load. And then like for like is not a good answer if they get a complaint. So that's the point of that one. So I don't know if we have any comic book fans, but that's Bane there on the left. This is flexible wire helix duct, technically what it's called. What do we all call it? We all, of course, call it flex duct, right? That is without a doubt the bane of airflow. Back in the day, sheet metal, a whole lot better, sheet metal elbows, sheet metal trunk lines, sheet metal. I was teaching a class at BPI, and there's actually one code official. Oh, I can't remember his city. He's just outside of Conroe, but all of his new homes have sheet metal duct. I'm like, did you incorporate that into is that by ordinance? And he's like, no, I used to be an HVAC contractor and it works better. And I was like, well, how do you make them doing it? Well, because I basically, the old red tag enforcement process, you're never going to pass a flex duct inspection. And so his guys, and he actually amended out the duct testing requirement. He goes, man, I'll look at every single seam. If they're mastic and it still fails, what are they going to do? So he approached it a different way. But for 99 homes out of 100 in Texas, we're going to see flex duct. Down in the valley, McAllen, Brownsville, it's all duct board, oddly enough. In El Paso, you can't use more than 10 foot of flex unless it's designed. There's a few jurisdictions here and there that you don't have flex, but the vast majority of us are dealing with flex. And we'll look at a lot of best practices and things to call out in your inspections on flex duct problems.
Jason,
so again,
sorry to interrupt. Can we stop for a few questions here?
Sure.
Okay. One of them is, what is suggested what is the suggested comfortable humidity percentage for the inside of a home?
40 to 60 is what we're typically looking at. Now, of course,
Okay.
in Lubbock, Texas, you're never going to get that high. And in Beaumont, you're going to struggle to stay at 60, but 40 to 60 is the typical. 50%, but you typically hear people say 40 to 60. But it's like a lot of things, comfort. You know, that there are some people that really are uncomfortable and they'll spend for a whole house dehumidification to keep it lower. And then there's, I went to school at Texas Tech. I was fine in the dry climate, but there were some people that couldn't stand it and had, you know, humidifiers. But yeah, 40 to 60.
Thank you. Next one is, isn't 2015 IECC code required throughout the state of Texas, regardless of what the code local jurisdiction follows?
You missed my first presentation, and we talked all about that. But yes and no. So for residential construction, as of September 1st of 2016, the minimum energy code for any home built in the state of Texas, whether you're in the unincorporated areas of the county or if you're in the middle of Dallas, was the 2015 energy code. So all homes permitted after September 1st, 2016, are on or after September 1st of 2016, should have met at least the 2015 energy code. Now, there's a handful of jurisdictions that have already adopted the 2018. That basically so that came from House Bill 1736. And House Bill 1736 basically said that the 2015 is the minimum energy code starting fall of 2016. And we're not going to adopt a new energy code till at least the 2021. And there's a few other little things in there. Energy inspections have to be done by code certified inspectors. They had some commercial provisions, some state building provisions, but yes, the long answer short, yes, all currently constructed homes in Texas should meet the 2015 or more stringent energy code, whether the jurisdiction has adopted it or not. I'm helping a jurisdiction right now in the DFW area. They're on the 2003 energy code still. I have a jurisdiction down in the valley that's still on the 1978 Southern Building Code. But it doesn't matter. By state law, yes, you have to meet at least the 2015 energy code. And the 2015 energy code requires blower door and duct blaster testing.
Okay, a couple more here. And if we don't get through all of them, I can always send them to you or give out your email after the presentation.
I love the questions. That's the fun part because I can make the presentation go a little faster to make room for the questions. So let's do them all.
Okay, what specific comment, the SOP suggests inspectors are not required to state the adequacy of the unit. What specific comment would you suggest to state if a system is oversized?
What specific comment? So what I would say, if I was doing a final inspection on a real estate or, you know, a real estate inspection, you're not going to have the luxury of the load calculations in front of you. So what I would write is that the 2015 energy code requires load calculations. Load calculations typically, in almost all cases, size HVAC equipment at 700 square foot per ton or greater. This home is, you know, you go out there, it's a 2,000 square foot house and it's a 5-ton. This home's AC is sized at 400 square foot per ton. Air conditioner is likely oversized. And then, you know, you could even suggest you may want to follow up with the builder or HVAC contractor for a copy of the manual J load calculation. But I probably wouldn't write up anything about the size of the equipment if they were 700 square foot per ton or greater. But the second they get below 700 square foot per ton, I would want to warn the homeowner that it is almost certainly oversized, and I would want to advise them that they might want to inquire about the manual J load calculations. That would be the tact I would take. And I'm happy, shoot me an email and I can give you some code excerpts or references, or I don't mind writing it up for you, but something along those lines.
Okay,
Next
next one. What do you think about R8 flex duct?
I think it stinks. I mean, it's better than R6, which is better than R4. But if we're going to put our piece of equipment in our 140-degree attic, okay, so I don't know if y'all are familiar with delta T. So heat always moves from hot to cold, right? Well, so if we're delivering 50-degree air and we have a 140-degree attic, the delta T between that 50-degree air and that 140-degree attic is what, 90 degrees? Well, the bigger the delta T, the faster that heat's going to want to transfer. Well, so we've got a massive delta T and we have this thick a piece of R8 flex duct to keep that 140-degree air from penetrating into our valuable paid for chilled air. So I think it's junk. But so an energy code requires a minimum of R8 flex, and that would be another thing I would write up in my reports. If you see R6 flex duct, it could possibly be allowed by energy code, because if they do the performance calculations, they can trade off that R2 difference and make it up other places. But the way to write that up to at least alert the people that there might be an issue here, I would write up the prescriptive energy code requires R8 flex duct. So then you're 100% correct if it's written that way. And the onus would be on the builder or home seller to say, yes, but we did a performance energy code, and so we were allowed to do the R6. Here's a copy of the performance report, problem solved. But if you see R6 flex, I would certainly notate on my inspection report that the prescriptive energy code requires R8 flex duct. That's how I'd write it up. Next one.
What's the max design outside air temperature? Can 900 square feet per ton keep up with 100-degree days in Houston?
Absolutely, all day long. Now, could it keep up with if you were trying to keep a tent cold? No, it wouldn't. But you have this lovely thing called a building thermal envelope on a house, and that 100-degree outside air is being significantly slowed through that wall assembly. If you're trying to, I mean, you need that 20 delta T of 20, right? I mean, or otherwise it's not going to work. Well, that heat doesn't transfer through that wall or ceiling immediately. So that's a myth that a lot of people say, well, I don't want to be 80 degrees in my house. There's a 20-degree delta T. Yeah, if you're cooling a tent, you're not cooling a tent. You're cooling a house, which has thermal resistance. It doesn't work that way. That's a common myth that isn't true. Now, is it going to keep your house 72 if you've got 40 people over for a dinner party and y'all are going in and out? Well, of course not. But you don't want to size your HVAC for your dinner party. You want to size it for the other 364 days of the year when you're living in that house normally. And what I would tell a homeowner, do you want your HVAC sized for one day a year? Do you want it sized for all year? And when you're going to have that dinner party, Mr. Homeowner, if you're comfortable at 72 degrees, well, 3 or 4 hours prior to your dinner party, knock it down to 68, start pre-cooling your house. That way your couch and all of the thermal mass inside your house will get to 68 degrees. The air temperature will get to 68 degrees. And then when you start going in or out in that thermostat's on 72, your air conditioning equipment has a whole lot better chance of keeping people comfortable at the dinner party. But again, you want to use some pre-cooling. You want to do other things rather than just grossly oversizing your system for your 1 or 2 or 3 or 4 dinner parties a year. The next one.
Only 10 AHJ require the manuals J, S, and D. Who are they?
Let's see. Austin requires it. Well, Austin at least requires a manual J. El Paso requires a manual J. South Lake, I think Irving, there's 3 or 4. Frisco. I don't know them all off the top of my head, but there's just a handful. Now, there's a handful more that require a copy of the manual J permit. They never look at it. Those are the ones that I know that actually do a little scrutiny of it. Next one.
What happens if you oversize the coil and have a smaller compressor installed?
Yeah, well, there's a variety of problems that could come from that, but I don't think you can always say what happens. Now, technically, if you're doing it by the letter of the law, you're doing a manual S and you're selecting the equipment correctly. But depending on CFM and latent versus sensible, there could possibly be a reason to mismatch that. But it would need to be allowed by the manufacturer, and it would need to be done for a reason, not just because of an oops.
Okay, next one. Builders wouldn't need to calculate manual J for every build, just every plan, correct? I mean, if they're working the same plan over and over, there doesn't seem to be a need for a new calculation.
No, there absolutely wouldn't be. Now, what you would want to do, now, if you're building that same build over and over, and one wall of the house is 60% glass, well, if that wall faces west versus if that wall faces north, is going to significantly change your heat load calculation. So what code would require? Code would require, you could do one for all of the 4 cardinal orientations. So what code would allow you to do was do a load calculation on a north facing, south, east, and west. And then depending on which way the closest that house went, you could just do 4 load calculations for one plan. And you would just use those 4 cardinal orientations.
And the last one is just a comment. I still am seeing flex duct coming off the top of plenum. Builders are getting away by saying that the building is meeting the energy performance rating.
Yeah, that doesn't, that's a builder that doesn't know what he's talking about. And he's conflating 2 things that aren't necessarily related. Now, technically, and I've recently gone through Manual D again. And Manual D, the thing about Manual D, you might be able to come off the top and the sides of the plenum. You actually might be able to, but it all has to be done per Manual D, and Manual D takes all of that into consideration. So, if again, it's one of those kind of gray areas. But to me, as a real estate inspector, if I'm thinking, what I would write up is, again, typically takeoffs from the plenum are sides only. This may be allowed per Manual D. You may want to refer to the Manual D duct design, or, just to let them know. We got to put some pressure on these builders to start doing it right, because I guarantee you they didn't do the Manual D, or it wouldn't be that way. And the best practices, like the rule of thumb best practice, would be to extend that plenum out long enough that you've got, well, and I'll come to it more in a minute, but your only takeoffs off the side. And there's been a handful of white papers written on this. The National Resource Sufficiency Lab, NREL, I don't remember what their acronym stands for exactly. They did a big study. A lot of these pictures you'll see coming up in the presentation are from their airflow study and how it works. And basically, you're going to screw up your static pressure. You're not going to get the CFM you need to the rooms you need it in if you just coming off the plenum all haphazardly. You really want all your ducts in a line, all off the side, at least 18 inches before the first takeoff, at least 12 inches after the last. I mean, but again, it's hard to write that up, because the Manual D, it allows as long as the math works, you can design your system however you want. But to me, I would write it up such that, typically takeoffs on the plenum are off the sides only. Manual D may allow this, but just some sort of note on there that, hey, I'm catching this, you know, I'm seeing that takeoffs off the top and the sides off of plenum is a pretty good red flag that they haven't done a manual D. Now maybe it's sized right and maybe it works right. I don't necessarily doubt that, but I can almost assure you it wasn't done by the book.
We have like 3 more. Do you want to take them now or just continue on to the next?
Where are we at on time? 10:48. Yeah, go ahead. And I'll just
Okay.
kind of speed up through the rest of it.
Okay, it says you hit on undersized return ducts. How is the best way to determine if it is undersized? I have used the actual size of the air handler return to determine.
Okay, there's again, that's going to, without doing all the you're not going to be able to determine that. Quite honestly, you're just not. But if it just has one return, it almost certainly is. So again, it's unfortunate that because of the way the HVAC design works, and you will get a handout. You'll get a copy of this presentation, but there's also a 1-page, or it's actually 3-page, basic mechanical code guideline that talks about some flex duct myths, and it gives you some rules of thumb. Basically, if you just have one return in a 3-bedroom house, I can almost guarantee you it's undersized. But without doing, I mean, if they had R25 walls and R60 ceiling, well, then it might be adequate because the equipment might be small enough that 16-inch duct might serve the return. But there's a good undercut. I'll cover that more in the following slides. Let's do the next couple and then I'll keep going.
Next one says, I am seeing a lot of new homes with only jumper ducts installed at bedrooms. Is the unit getting enough return air?
Most likely, if it just has that one 16-inch return on a 20 by 25, most likely not. Most likely you needed 2 of them. I mean, we're seeing returns. It's pretty typical to see returns about half the size that they need to be. So most likely not, but you don't know for sure. A jumper duct typically is going to work better than an undercut, and I'll show you some more on that as we go. I'll cover that more later too. All right, last one, and then I'll keep going.
Okay, in West Texas, we see the evap coil being sized up 1 ton over the compressor when there's a sprayed foam attic and the system is located in the attic. Is that okay? What effect does the foam attic have on the size discrepancy?
I don't know necessarily that the foam itself has an effect on the size discrepancy. I'm guessing that's not the best practice, but again, because y'all's latent and sensible out there, you don't have a, you don't have a whole lot of moisture to be removed. I can almost guarantee you it wasn't done by the book, but I can't tell you for sure the reasoning why that HVAC contractor would have done that. You typically, I would write up coil doesn't match outdoor unit and leave it up for the HVAC contractor to explain why, but there's nothing specific to foam that would cause them to do that, or there shouldn't be. I mean, now of course, foam makes a tighter house and it gets your mechanicals in conditioned space, but that doesn't necessarily mean you need to mismatch your equipment. I mean, so I would definitely point out the mismatch of equipment every time. But that video you saw from Alex, he does a whole hour and a half for us on manual S, and we have like 60 videos on our YouTube channel, by the way, and he does 4 of them that are just phenomenal. If you really want to gain a greater understanding of manual JS and D and what all is required and how the calculations work, I'd highly recommend you watch those videos. I'll show another little snippet of one here in a minute when we get to it. But every house is different. Every situation is different. I'm assuming everybody kind of read through what we're looking at there. These are just some manual D. So yeah, so this is what all manual D is looking at. It's like, okay, we've got our load calculations. Okay. We've got our blower performance. So that's our manual S. So manual D is going to develop an understanding of how the duct system works completely. We're about to talk about equivalent length and effective length. And then also you have to evaluate your pressure drop across the components, right? About static pressure. And then we're going to use our friction rate to decide our duct size. And then obviously we want to think about noise. So that's just kind of an overview of the manual D procedure. And we're not going to worry about this because we're running a little behind with the questions. So let's get to, so if you're seeing these field boxes, just FYI, manual D, a metal Y is way better. A field fabricated junction box like this, manual D is going to assign 95 feet of effective length for that, whereas a metal Y would only be 15. So that makes a big difference, and I'll show you some more on those calculations, how that works. Then this comes off. You typically, this is junction box sizing as well, but a lot of this holds true for a plenum as well. You want at least 2 times the duct width, the first takeoff. This 18 inches is a good rule of thumb. What you're typically seeing in new construction is teeny tiny plenums with takeoff starting here and off the top and everywhere. Well, the way airflow works, you get turbulence in these back corners and then in these corners. And so that's why you want the takeoffs that 2 to 3 times 18 inches. 18 inches here, 12 inches here. Those are best practices. If you do have a junction box and maybe you've got this and you've got some rooms, you want the longest outlets on the back end of the box, not like this, right? You want the furthest outlets on the back end because, again, the airflow isn't as great at the front of any of these junction boxes. Actually, I think it was Jeff sent me these pictures. There is if I'm up in the attic and I see this, squeeze on that and make sure there's a piece of metal in there. There's actually an HVAC contractor in the San Antonio area going around and he's just cutting a hole in the liner, stabbing this other liner in and pooking the heck out of it. Just covering it with mastic. So you should be able to feel a hard, you have to have a hard metal collar on any of these junctions like this, or the junction box with the collars and mastic and sealed. Again, so yeah, you asked the earlier question, takeoffs off the top, you're seeing this all the time. I would absolutely write this up because really, I would just write it, best practice for plenums is takeoffs only off the sides, not off the top or bottom. That is 100% accurate. And the onus is on the HVAC contractor then to show the builder, so the builder can provide it to the home buyer that, oh no, this is right because we did our manual D calculations 100% by the letter of the law. No, you didn't. What you should have done, this plenum should have been 2 to 3 times longer. It should have gone in between these truss cavities, gone in between this truss cavity here, and all of these ducts should have been 18 inches for the first takeoff, and they should have all been side by side off that, and with 12 to 18 inches in the back. So these are the flex duct manufacturers guidelines. This is for all. There's individual flex duct manufacturers don't have specific instructions, but there's a flex duct manufacturers council or guideline, and they all follow the same installation instructions. So coming off the plenum, you could write this up all day. Coming off the plenum, within 1 duct diameter, coming off the plenum, it's supposed to do 2 things. It's supposed to come straight off the plenum. How often do you see it going down immediately or up immediately? It's supposed to come straight off the plenum, at least 1 duct diameter, and it's supposed to be supported off this plenum no further than 1 duct diameter. So that you see that wrong all the time. You see this all the time. They had a little 10-foot section left over of flex, rather cutting it to 6 feet to fit. They'll just, oh, I don't have to cut it if I just use the 10-foot. You want flex 3 things. You're looking for 3 things for flex duct. You want to get smooth, sealed, and separated. And it's not going to be smooth if it's scrunched up like this. And there's some more slides coming up that show that puts some math onto how important that is. So what all are we looking at wrong here? A bunch of stuff, right? So now granted, Perhaps this was done 100% by manual D, and there's a diffuser in here right as it delivers, and there's dampers and all this. I doubt it. I don't see any dampers here anywhere. I mean, this room right here is probably really cool in the summer and really hot in the winter. No telling with these. So flex duct, what are we supposed to come off the plenum, right? One whole duct diameter before we go down. These straps here, what's wrong? So these can be no further than 4 feet apart. In between the supports, it's not supposed to sag more than a 1/2 inch per foot, right? So you draw a straight line between those supports, no more than 2 inches of sag, that's about 6. This isn't smooth, right? I mean, they should have taken 2 or 3 feet off this flex duct. So that's what it's supposed to look like. It's supposed to be smooth because it's supposed to be stretched tight. Smooth, sealed, and especially in humid climates, it needs to be separated. If in Houston, if these 2 flex ducts are touching each other, you will get condensation. You need at least 1 inch of separation. So for this to have been done right, it wouldn't have been that hard. The return here just needs to have a couple of feet cutting off and have it tightened up, better supported, right? The supply, this plenum needs to be 2 to 3 times longer. All the takeoffs off the side, straight off, stretched tight. Any bends in flex duct, at least, so if this is a 16-inch flex duct, you need at least a 16-inch diameter or greater bend, right? Certainly not like that. Luckily, that's probably grossly undersized too, but then they put in a 5-ton when they needed a 2-ton. That's got to be Bryan College Station. Or that, right? It's just like, man, they went out of their way to make that crummy. But hey, they're comfortable. It's ridiculous. Before and after sharp bends. So any sharp bend in flex duct, you're supposed to have a support within 1 duct diameter before and after the sharp bends. We already talked about this. No further than 4 feet between spacers, no more than a 1/2 inch per foot sag. Now, you shouldn't be riding up flex duct laying on joist because all the flex duct says is this support has to be 1.5 inches wide. Well, a joist, a 2x4 piece of nominal lumber, is 1.5 inches wide. So you can lay it across the joist. And actually, there's a provision in the Energy Code, the 2018 Energy Code, that it's called buried ducts. You put R19 under the flex duct. So in that 2x6 cavity, you've got R19. Then you run your flex, and then you pile up R19 on top of it. So a full 6 inches on top of it. So when you look in the attic, you don't see any flex anywhere. You just see mounds of where the flex is underneath it. And it allows you to count that entire duct system as having an insulation value of R25 for your Energy Code performance calculations at permit. And then if you get your air handler in conditioned space, and there's one more, oh yeah, you have to test it. It has to leak less than 1.5 CFM. But then you can say that whole system is in conditioned space for your performance calculations. But for track inspections, don't be thrown off. You're going to see more and more buried ducts in attics. It is allowed, and in fact, it is a provision in the 2018 Energy Code. We do have a full webinar on buried ducts in the Energy Code. If you want to learn more about that, that's on our Spear channel as well on YouTube. And if you subscribe to the channel, you get all the updates when we add videos. I add about 2 or 3 videos a month to it. And it's not always me blabbing, so I'm assuming none of y'all want to hear me anymore. I get really good speakers from all across the country. I mean, chief scientists from PNNL and ACCA and Spray Polyurethane Foam Alliance. I get some really sharp people giving webinars, so you're in for much better quality if you're listening to them instead of me. What we got wrong here, right? Well, why in the world couldn't we have come straight off this plenum, ideally a metal elbow 90, and boom. Instead, we're going to send all this air up here. But perhaps it was done per manual D, but is this smooth? No, it wasn't. I mean, that's about 2 to 3 feet longer than it needs to be. Smooth, sealed, separated. I would be noting that all the time. Flex ducts should be stretched tight, smooth, sealed, and separated. It shouldn't be crimped over framing members. It's more important. You'll see this like on bonus rooms like this. So what are some problems with this, you know? Oh, well, our little bonus room, we just, put a 16-inch supply up there. Well, we've got what is that? 8 inches. That is a raised heel truss. So maybe we got 10 inches. 10 inches. I've got a 16-inch piece of flex. I think I can live with it being compressed and egged a little. And I can probably live with the egging of the duct. Yeah, okay. But what I can't live with, we've all felt flex ducts, right? This isn't like an R8 duct board. R8 duct board's pretty firm, right? You can touch R8 duct board and it's pretty firm. This R8 is pretty squishy. So our air that we're paying to cool has got about an R1. After you squish that R8 down onto the liner, you've got about an R1. And this underside of roof deck, 160 degrees pretty easily. So we've got 160 degree material touching R1 to R2 compressed R8 flex duct. And then what else we got problems with? See these little shiny things here? These are roofing nails. I can't tell you how often, that mechanical contractors do this blows me away. And not only that, this air is carrying some moisture with it. You got those little holes. You're going to get moldy spots on your roof deck. So there's really 3 main problems here. One, they probably should have ran 2 so they didn't have to egg it. But the things I'm really worried about, what you need to do in this situation, cut you a little piece of duct board. You can just stick it right in place. It'll stick to those roofing nails. So you stop the thermal bridging into your airflow because that R8 flex board is denser. You stop the poking holes of the roof nails because you've got some protection. And you stop the thermal bridging. I already said that. So that if you ever see flex duct should not be touching the roof deck without protection. Write that up every single time. Why does it matter if it's not smooth, right? Well, smooth is indicative of it being stretched right? Well, we already talked about flexible duct is flexible wire helix. Well, what's a wire helix? It's just like a rib. It's like a slinky, and if you stretch it tight, you're looking at 0 to 4% loss, or 0 to 4%, basically as tight as you can get it. You plug this in and your manual D is just your normal friction rate. Well, if flex duct comes in 25-foot sections, right? And well, it's 20 foot from the plenum to the boot. I'm just going to kind of scrunch it up a little bit. That's only 15% compression, but the heck, they don't have to cut 5 foot off. No, that'll be quicker. At just 15% compression, the air going through a piece of flex will double the friction. I see that. I'm not going to rat out the jurisdictions. There's one just south of here and one where Aggies go. You see this all over the place. 4 times the friction rate at 30% compression on the flex duct. So please call out smooth, sealed, separated. Call out that the flex duct should be, straight out of code. It's straight out of manufacturer's installation instructions, should be cut to fit. Flex duct should be cut to fit. So how does Manual D do these calculations? Let's look at this example. This is straight out of the flex duct manufacturer's installation instructions. So we've got a supply plenum coming off. Imagine this is a supply plenum. We've got our little collar with a flex duct attached to the supply plenum, a couple of 45s as it goes down to the joist, goes across. We got a 90-degree bend here, collar or boot here. 12 foot is the total length. So what just think in your head, what is the total effective length Manual D might assign for that? Oh, and then while you're thinking about this, I want to show this one other little video. Again, this is the Alex meeting with RightSoft. And this is more to deal with flex duct sizing, but think about mechanical contractors saying, it's
easier to start with. You showed up, so you probably know that air sizing duct systems is important. But I do occasionally encounter an attitude of it's not that big a deal. It's a 7 versus an 8. And so I do like to show this. This is actually, I built this into this presentation, but I show something like this. And it's, this is how people think ductwork right here, this bottom line. It goes from 5 to 6 to 7 to 8 to 9 to 10. But when you think of the area inside that duct, this is how duct size increases. right? And so you're not actually talking about a difference between a 7 and 8. You're talking about the difference between 39 and 50, which is a much bigger difference when you look at it, right?
Right. So that 1 inch, that's just to kind of highlight that 1 inch difference makes a big deal. It really does. So let's get back to these guessing. The guessing of, so again, total effective length of this duct run per manual D. And I'm going to speed it up a little bit. So here's how you calculate it. And you come in, we're looking at 124 feet total effective length, because each of those fittings, each of those bends, that 90-degree bend adds 20 feet effective length. 245s adds 20 feet effective length. Exit fitting, entrance fitting. This is straight out of manual D. So all boots aren't the same, right? Look at this. The effective length of this one, 60 feet. The effective length of this one, 20, 10. I mean, I see these as low as 10 and as high as 100. This one right here is 100. It's going to add 100 feet of total effective length. So every manufacturer of these boots, they have their airflow tested and they all have effective lengths, and all of this gets put into the calculations for a duct system done correctly. Some more things. We already mentioned that splices need metal, or splicings or junctions. They have to have a sleeve. The plenum has to have a collar. There's nothing unknown about that. Technically, don't if you're siding, the jacket hasn't been masticed, it doesn't have to be masticed. The jacket doesn't. The liner has to be masticed, but the jacket doesn't. Some jurisdictions do. I think it's best practice to go ahead and mastic the jacket as well, but it's really just the liner that has to be masticed. And you can typically, if you remove a diffuser, you can reach up in there and feel the mastic on the seal up in the boot to see if they've masticed the liner. You'll see this in Austin on all new construction. You will see balancing dampers at the plenum, because Austin requires on residential construction test and balance, and it has to be within, what was it? I think 10 CFM within, I think it might have been 10 CFM of design. So yeah, they're actually verifying the test and balance of each bedroom meets the design of the system. And you can't accomplish that with just your damper at the diffuser, just the old school way of doing it. But in most jurisdictions, you won't find these dampers. Just if you do see the damper in a plenum, so this damper runs this way, right? So as you're closing off the airflow to this duct, the damper is still going to be horizontal in the plenum, horizontal versus the airflow. You don't ever want to see these dampers up on the top, because then what happens? Then it's vertical to the airflow, and that you're creating a bunch more turbulence. So that would just be something to note. If you do see the dampers at the plenum, the adjustments need to be on the sides or in line with the airflow. I remember the first time, I wonder if any of y'all remember this, the first time I was doing a final inspection on a house, and I walk up into the attic and I'm like, hold on, supply, return, plan. What in the world is going on? This HVAC contractor was on drugs. What in the heck? I've got a duct running from the supply to the return. And ACCA actually has a manual for this, ACCA Manual ZR. It's all about zone systems. One of the best webinars we've given, and I want to play about 2 more minutes of a video, and this will definitely need to be something that you want to highlight on your report. If you do see a zone system, there are some requirements. You can't just have a gravity damper. It can't just, I guarantee you, Carrier will not allow this. I mean, code doesn't specifically call it out because code doesn't get that particular, but I can promise you the manufacturer doesn't allow this. I want to show you real quickly the way it should be done.
So we're going to go through it. Old school bypass duct design. Each and every one of y'all have ran into this situation. We've installed it, and I'll agree, I've even installed them this way. We have our bypass duct coming off of the supply plenum, and then hanging over the top of the unit, we'll mount our bypass and then bringing it back into the return plenum. And if you're lucky enough to have a 4-foot return plenum, heck, we thought we were in high cotton there. And then our return duct is going into the back of the unit. Well, this situation we've discovered has been part of our problem since the variable speed blower has came out. If we looked at, again, the variable speed blower, how it deals with that back pressure or resistance against the blower wheel, if I had all zones calling, theoretically, this bypass damper is closed. Well, with it sitting closed, we now have stagnant air halfway up this bypass duct. So guess what happens on this bypass duct? We start to gather a little moisture going on because that cold air is just sitting there. It's not traveling, it's stagnant. So that was the first situation that we came across. Then what we had, where I would take phone calls, David, I need extra, if y'all remember the arm and weight bypass, I need extra weights. Well, everybody thought that.
Yeah, if you see an arm and weight bypass damper on a zone system, I would call it out. It is not allowed by the manufacturer specifically, almost every time. So, and I'm going to finish this. This is really some good things to think about.
Heck, the bypass couldn't set it properly, so they would add extra weights on here. And heck, I've seen boxes of washers, transformers, vice grips, coat hangers, anything to try and tie that metal arm from actually swinging all the way open. Well, the situation was not necessarily that the bypass was bad, sized wrong, designed wrong. The problem was that particular duct layout with a variable speed. Again, if I had all zones calling, theoretically the bypass damper is closed. Once a zone is satisfied, that zone damper starts to go closed. What does the bypass damper do? Well, static in the duct builds, so now it pushes this bypass damper open. This bypass duct is a double static. We have a supply push and a return pull. Well, with it being a double static, as soon as this bypass damper opened up, what happened to the static in the supply plenum? Well, it drops. So as it drops, what did our variable speed blower do? It starts to speed up. So as it speeds up, our bypass damper says, hey, I've got more air. I need to open up more. So it opens up more. Then the variable speed ramps up more. Bypass opens up more. They sat there and fought each other until this variable speed couldn't push any more air. It's just screaming. That was part of the situation. Now let's add to it. This air is flying through the bypass duct, flying through the return plenum, bouncing on the bottom of the return, and then going through the unit. Well, as it flies across the back of the as it flies across the back of the return plenum, what did I now create right here? This return air is trying to get in here. This bypass air says, no, you're not. I'm throwing an air curtain inside this plenum. Well, now that there's an air curtain here, I can't get return air. The unit is starving for air. Where does it make its air up from? The bypass duct. So now we just have a ton of air flying through this bypass going around and around in circles. Now there was a situation, if you remember, I'd take phone calls. David, I actually have water dripping off the coil and flying into the supply duct. Here's your reason why. We had no static on the air handler anymore. This bypass air is flying through. There's no static to bring the water down into the drain. So the ACCA Manual Z addresses this, and that actual engineer, which by the way, it's kind of an interesting thought that ACCA hired an engineer from outside the air conditioning industry. They hired a mathematician to go through this zoning scenario. And the guy asked for our design, all the zoning manufacturers, what are your theories and design thoughts on zoning? Well, one of the situations that we did on a design was rather than bringing the bypass back to the return, I would promote going to a mixing box, have that bypass into the mixing box, have the remote returns into their mixing box, let it pressurize mix there before coming back in through the air handler. And that gives us a better mix of bypass and return air. Well, this mathematician said, yeah, kind of theoretically, yeah, that's what you were doing. However, what you actually did was you added static to the bypass. And that, my friends, is what we're going to do with our bypasses now. So if I have anybody that runs into an arm and weight bypass out there, we need to change how our bypass duct is installed. Instead of having that bypass sitting in the middle of our bypass duct, we are now going to mount it on the supply plenum. I want that bypass when it's in the closed position to make sure that all the air remains in the supply plenum traveling down the ducts. The only time that I want air in this bypass duct is when it's necessary. So as the bypass goes through return, now we go over here, we have a manual damper collar installed. This manual damper collar is what is going to give us our static. As the bypass air travels through the bypass duct, it hits this stationary damper, sending static back through the bypass duct, back to the air handler, making sure that our variable speed blowers don't hunt. They maintain a constant speed. I also promote in my training classes, we take our return plenums and we want them to be tied in front of the bypass duct.
You can pretty easily see that zone systems oftentimes are not done correctly. And that's just kind of the highlight. That's a great video. He does a good job with that video. If you want to learn more about zone systems, I'd recommend it. Let's blow through here. So that's kind of what we talked about already. So we talked about return air strategies, right? And really, for it to be 100% done correctly, you're going to use manual D. And I'll show the handout real quick and just kind of show you some myths about duct design and return air sizing. We certainly don't want one here, right? But I can tell you, if you're just using one return, it's almost certainly undersized, whether you got jumpers in the bedrooms or not. It's still not, depending on the CFM for the equipment, it's almost certainly undersized with just one return. I mean, I would be writing that up all day long. So let's imagine we've got our master bedroom with a couple of 65 CFM supplies for the bedroom. Maybe we got a 60 CFM going to the bathroom, and maybe a 25 or 30 CFM going to the master closet. Well, we're just going to do an undercut. You cut an inch off the door, you're fine. Well, that's between 200 and 300 CFM to that master bedroom. On a 36-inch door, I'm going to need a 4-inch undercut. This is straight out of manual D, right? Who wants between a 2.7 and a 4-inch? Or on a big master bedroom, you might have 400 CFM, a 5.3-inch door undercut. So if you don't have a return in the bedrooms, and there is no, even like small bedrooms, I mean, so I'd be writing this up left and right for undercut, not a proper return air pathway. So just real quickly, some energy code considerations that have to do with HVAC. Sealing the boot to the drywall. That all new homes from the 2009 energy code on. So for a long time in Texas, penetrations through and that's your number one energy penalty is air infiltration. Your number one air infiltration spot is the ceiling. All of the can lights and HVAC and exhaust ducts, all of those cut in the ceiling. You can seal them from below or above. When I give this presentation to builders, or give similar presentations to builders, not this one, but it's like, man, who's got caulk on the truck? The painter. What does the painter do before he paints the ceiling? He removes the can light trims. He removes the fart fan trim. He removes all that. Caulk it, caulk all, and code specifically it doesn't require what it to be sealed with, but energy code requires the boot sealed to the drywall. This is what a duct blaster looks like. If anybody hasn't seen one before, basically pressurizes the duct system. And then you got a little manometer that measures the leakage. I mean, we've been getting a whole lot tighter. 20 years ago, the average was about 20% leakage. Now you have to be under 4. So just another reason to size it right and do it by the book. This is on the other end of it. So it pressurizes it. You typically look in the air handlers in place. If the air handler is in place, 4 CFM leakage is allowed in the 15 energy code. That's also in the 18 energy code. R8 flex duct is required unless you show in your performance calculations that you made up for having R6. Under no circumstance can you have less than R6. So I'm arguing if this cooler is R8, that probably meets energy code, right? Huh? Or that's, my wife's wanting to know why I'm spending so much time in the attic. Well, that's keeping your beer cold up there. Or maybe these 2 rooms aren't staying cold enough, a couple of blocks of dry ice in there. And you know that if this is up in the attic, that's the condenser for that system, no doubt, right? It's actually a condenser. That's too good. I mean, he's got his gauges hooked up to it and everything. Well, we see anything wrong here? And then this is, oh man, I wish we were sitting in a room because I could see a hand up or see some eyes raised. So Meritage does this a lot. They do a lot of junction boxes, top fed junction boxes with takeoffs off all the sides. And perhaps Meritage typically tries to do pretty right by energy efficient design. So perhaps this is all done by the book. I don't know for sure that it wasn't, but we looked at that total effective length earlier, right? And we talked about coming out of junction boxes and plenums straight, right? And as straight a run as possible. So if we were sitting in a room, I would ask, why didn't they just come straight through here? Well, the reason they didn't is this is a what? It's a TJI joist, right? Well, you're typically, if you're doing framing inspections, kind of a rule of thumb is off this load bearing point, you want at least 4 feet before you cut a hole. I used to carry this around in my truck when I was doing inspections for Granbury. And based on the TJI number, so based on what model number it is and what size hole you want to cut, this is how far off the load bearing you have to be before you cut that hole. So if you're doing inspections and you see TJIs and you see big holes cut near the load bearing point, I would write that up all day long because I can guarantee you, even a 6.5 inch hole, I mean, you're at least a couple of feet off on most of those. This I see quite a bit at, now this is a plumbing pipe. This is right out of the IRC. As far as HVAC related, I see it with line sets running through the exterior wall. And if you don't have some protection of that Armaflex on that metal strap, I guarantee you that's where you're going to get a refrigerant leak, because inevitably this moves a little bit when the air conditioner comes on and off. And that, you are going to get a refrigerant leak right there every single time if you don't protect that going through. You can see that at a final inspection. I mean, you can see that where that refrigerant line runs over into the top plate. And I would just kind of push it back a little bit. There's a brand new house. We were doing field training in Bryan the other day, and we got out of the truck, and I was like, I can tell you where they're going to have a refrigerant leak. And the building official's like, what? I go, come here and look. And we pushed this HVAC piping away. And it was this metal strap that was already completely through the Armaflex insulation, and there was a shiny line in the copper where it had already dug a little divot in the copper. I mean, so it's just you got to protect that. Ventilation. This is a little bit of a rant. I apologize for those of y'all that were in my earlier webinar because I've ranted on it there as well. But since a lot of you are new, I'm going to go ahead and go again. So with the 2012 Energy Code, the entire state of Texas had to be 5 air changes an hour or tighter. In the mechanical chapter of the IRC, it says if your house is 5 air changes an hour or tighter, you need mechanical ventilation. So, you know, and a builder, it's like, man, I spent all this extra money making my house real tight to quote unquote save energy, and then you're going to make me plug something in to bring in outdoor air? Well, yeah. I mean, I know you can't, there's a mantra in the energy efficiency world and in the energy code world that's called build it tight, ventilate it right. It is 100% impossible to build a house too tight. Raise your hand if you want holes in your house. You don't, right? You don't want any holes in your house. But you raise your hand if you don't like fresh air. Well, everybody likes breathing good air, right? Well, you're going to get a lot better air flow and you're going to get better air distribution if you make your house super tight and you bring in outside air from a known source, filtered at a known rate, and distribute it throughout the house. Now, code, it allows a few different ways. Code allows exhaust only, supply only, or balanced. If I'm doing a final inspection on a house and you'll see a lot of supply only strategies, which is they'll use the controller damper. Typically Honeywell is what I see most of. Different manufacturers make them. But they'll run a little 6-inch duct to the soffit, and then they'll come and they'll hit that damper, and then there'll be a controller on the air handler in the attic. And that's a supply only strategy. That is allowed by code. You can use exhaust only, supply only, or balance. Balance is like an ERB, HRB. Nobody does that really. The problem with this is it's a dumb supply only strategy, and it's dumb for a couple of reasons. So if I've got a 16-inch return going to this return plenum, and I've got 3 12-inch returns going to each bedroom into this return plenum, and then I've got a 6-inch duct going to the return. Well, how much air follows the path of least resistance? I'm going to have about 4 to 6 CFM coming in through that 6-inch duct. 80% of my air is coming through that 16-inch duct recirculating the house. You're not getting mechanical ventilation. You're getting circulation. We're needing a whole house mechanical ventilation system. And what code says, you can. And there's a couple of problems with doing the supply only. Number one, if you do it, it has to be on an efficient multiple speed air handler. It has to have, look back here, an electronically commutated motor, an ECM motor for short. Typically, you're looking at a 16 SEER or better for an ECM motor. So if you're just putting that old 14, 15 SEER builder grade air conditioner in there and you use that controller to hook up to it, well, in the shoulder seasons, when the air conditioner is not running, that controller is going to tell that air handler, hey, I need some outdoor air because we're not running. So it's going to make that air handler kick on at a 275 to 300 watt penalty to bring in 4 to 6 CFM of outdoor air and largely just recirculate the air in the house. So what the energy code says is, yeah, you can use supply only, but if you use supply only and the mechanical ventilation fans are part of the HVAC equipment, they have to be a multi-speed, an ECM motor. The cheapest way to do it is exhaust only. You can just the exhaust fan in any bathroom that you were going to install. All you have to do is install a little bit better exhaust fan. I'll show you. I don't have that. So basically, it has to meet. You can use exhaust only. It'll have to meet these rates. The exhaust only, it has to be basically a little better fan. That's all there is to it. You'll notice it's a little bigger housing. It's just a little beefier fan. It's not your normal little 8x8 builder grade junk. It's a little bit bigger fan. And what it is, it has to do with the efficacy of the fan. So energy code says it has to be 2.8 CFM per watt. We're not going to get into the weeds. What we're going to look at is, hey, if we don't have, if exhaust is the mechanical ventilation system, at least one of the exhaust fans, it will be typically labeled either Energy Star or 62.2 compliant. ASHRAE 62.2 is the committee that comes up with these ventilation rates that are required. So these are the whole house ventilation rates. But here's why it's broken in code. So I can, as a builder, I can be 100% code compliant. I upgrade one of my $40 exhaust fans to a $90 62.2 compliant or Energy Star exhaust fan. So that it's compliant by the efficacy per watt by that way. The only other code requirement, there's two. It has to meet this CFM rate. And then the third one is it has to be controlled. Well, a light switch is a control. All of those fans, even look at this, at 5 bedrooms, 4,500 square feet, I only need 90 CFM. Most of them are 100. So you're pretty much there. You just upgrade one exhaust fan, $50 extra, and boom, you meet the whole house ventilation requirements. But here's why it's broke, and here's why I hate it, is, you know, maybe production builders or people building that exact same house all over the place. Well, if me and my neighbor live in the exact same house, we both have a 4-bedroom let's say 3,200 square foot house. Well, me and my neighbor both need 90 CFM of continuous outdoor air coming into our house. Well, I love to open my windows. My kids go in and out all day. I don't ever cook in the house. I'm not creating indoor air quality particles by cooking too much. Got good hygiene and shower every day. We don't have any pets. Well, my neighbor, little old couple, 9 cats, 3 dogs, shower once a month, never open a door or a window. Even though our homes need drastically different indoor air quality requirements, code is going to say we need the exact same amount of outdoor air coming into each of these homes. It's broken. There's too many human variables at play to make this a code requirement. So as a real estate inspector doing a final inspection, I'm going to look for 2 things. One, if it is using that controller and you have that fresh air duct into the return plenum, we need to make sure it's an ECM motor. And if you're using exhaust only, technically one of your fans needs to be Energy Star 622 compliant, but reality is the builder is not going to tell them that's their whole house ventilation system, and the homeowner's just going to turn it off anyway. So who cares? And you know, everybody knows those things are made to remove moisture, not what everybody uses them for. So it's broken in the code. We're not going to worry about that. We're running a little behind, and I want to get to these extra resources. Everybody has that mechanic buddy with 3 broken down cars in the yard. There's no doubt there's an HVAC person that lives there, right? And that's their attic. So I want to show you just a few more resources, and I've got 7 minutes left, and then I can get through those resources in 7 minutes, and then we'll have plenty of time for questions. So let's just look at a few of these real quick. So again, we do have a YouTube channel. If you just Google SPEAR, S-P-E-R, communications, 60 different videos and over all sorts of building science stuff, smart ventilation strategies. These that Alex did were particularly good. This community control tales from the damp side, there were some real good ones there. So subscribe to our YouTube channel, it'd be great. If you'll Google Building America's Solution Center, I wish I'd have known about this when I was a code official. Click on building components. There's a bunch of other things as well, but on building components, maybe I'm looking at walls and openings. Let's see, wall structure. So, 10 different options. And then under each of these options, well, look how many different guides, double wall, stud framing, SIPs. So vented versus unvented attics. And each of these you can click on, okay, insulated corners and insulated headers. Yeah, that is quote unquote advanced framing, but that is also required by the Energy Code. Those both came into the 2012 Energy Code. And so under each of those tabs, there's a scope, description, success, there's pictures, there's training, there's where it's notated in the code. So Building America's Solution Center, fantastic resource. Next, construction instruction. This is actually also a free app available on your phone. I guarantee you nobody installed them. I love doing a presentation in front of builders, because after I introduce myself, and I always ask, so who builds their houses to code? Raise your hand. And inevitably a few suckers will raise their hand. And I was like, okay, let me show you this quick little video. And this is again a free app on your phone. So this is a 3-minute video. This is how to install. This is a Type A Tyvek flanged window installation instructions. About 10 seconds into this video, half of them lower their hand, and then as soon as they show the window sill being sloped 6 degrees, everybody else lowers their window. But all of these products have specific manufacturer's installation instructions. The cool thing about construction instruction is all of these little animations are language barrier proof, which is handy. It's a free app available on your phone. Hey, we got to seal that unfinished edge of the OSB. Yeah, that's required. It can't be touching the concrete. It can't be allowing moisture to wick up through it. It needs to be sealed. Flashing and caulk. Oh, yeah. If we're using the Tyvek as a weather barrier, as an air barrier, it also has to be caulked at the top. So this is a Type A flanged window install. And it's got about 2 minutes left. I'll go ahead and let it run, and then we'll cover these other resources and we'll be done. pan flashing at windows, man, that's a big pet peeve of mine. Number one water intrusion area in a home is at windows. If any of y'all are doing framing details, I just beg you to watch some weather resistant barrier details and look at some window manufacturers installation details, because nobody's doing this right. And ultimately you're going to get moisture and you're going to get rot. Look how you're supposed to cut this at a 45, 8 inches. You peel this back, then it's worth watching the rest of it just so you can show that how often it gets done wrong. But again, free app available on your phone. You can take it out in the field. Pan flashing is required by every window manufacturer in the world. You have to have a weather resistant material. Every window installation instructions I've seen, this right here, this sill plate, this is sloped 6 degrees. It's supposed to be sloped 6 degrees to the outside, because they know, especially vinyl windows, water is going to get in there and it needs to be sloped and drained out. You never caulk the bottom flange, right? You leave the bottom flange uncaulked. Fill every nail hole with an appropriate nail rather than torn off the nail gun and just hammered through the plastic. It's got to go an inch above the top flange minimum, right? And then you fold that top flap back over shingle style, or tape it, then fold. How often do you see framers with the roller on the truck? Never. I mean, this is, I feel bad about, I didn't do a very good inspection on windows when I was a building official. And I feel bad because I know there's probably some people in Granbury that have some window intrusion or water intrusion at their windows because I didn't do it correctly. But that's how you do it correctly. Construction instruction, great resource. If you really want to get into the nitty gritty, some of the white papers and some of the big nasty details, Joe Stebrecht's Building Science Corporation, all their articles and papers are free. And man, some of the ventilation, unventilated attic work he's done, there's videos and there's white papers, air sealing guides. Building Science Corporation is a great resource. If you are doing insulation inspections, typically our insulation installers are Spanish speaking folks. This is a 12-page pictorial guide in Spanish that shows every way, rhyme, reason, how to install insulation. It's fantastic because, I mean, give me pictures all day long, right? And if you're trying to translate it to the folks doing the job, you want it in their language. So this is a great resource. The Building Energy Codes program through DOE, look at all these different videos available. Res check, buried ducts. I mentioned buried ducts. There's a buried ducts one, basic HVAC controls and energy codes. You see about 40 videos there. This is the training tab of the Building Energy Codes program. Fantastic resource. Residential Energy Dynamics. This one's pretty cool as well. There's some free like ventilation calculation, ventilation sizing, airflow measurements, insulation R value. There's a bunch of different little tools, and some of these apps are available on your phone as well. You know, where am I building? What's the floor area, occupants? What's my leakage? What kind of CFM am I going to need? Residential Energy Dynamics, that's a pretty handy one. And that's it. And it looks, real quick, and then there will be additional HVAC resources here. Everybody will get a copy of this. So this design considerations, this talks about return air filter sizes, and it gives some examples of how to do it. And it's going to be based on the width and height of the grill size, what kind of square footage opening it is, and how many CFM you need for that system. And it just kind of shows some rules of thumb and some ways that it's typically done wrong. And this is all in one Word document. Please fill in, and my email address is on here as well if you have any future questions. And then what I did, all these bullet points, I took all of the requirements out of the mechanical chapter in the IRC. Things like the passageway to the HVAC equipment, things about, I guarantee you, y'all are seeing this done wrong all the time. The walkway to the equipment and the service deck, What do they always use for that? 7/16 OSB, right? 7/16 OSB is gonna, I mean, it's, you get a 300-pound HVAC, you've got repairmen carrying a piece of equipment, that ain't thick enough. Code requires a minimum 5/8 inch if joists are 16 inches on center, 3/4 if 24. So just, I basically took all the requirements in the mechanical code chapter of the IRC and all of the stuff that you typically see, just made little bullet points. You'll get that as a resource. And that's it. If we want to field the rest of the questions, and we'll get you guys out on time.